somehow the laws of physics changed and magnetism no longer affected our lives, we'd lose a lot more than our television reception. So stay tuned. Magnetism has been with us since the Big Bang. It's as fundamental to our world as gravity. But until the early 1800s, scientists believed magnetism was limited to magnets, like lodestone, a naturally magnetic rock. We're learning. Just ask Dr. Joshua Lederer.
Today we know that the origins of all magnetism are in the atom. And it comes from the way the world works. The way the world works is the atom consists of electrical charges. They have names, the electron and the nucleus. That's essentially the two parts of the atom. And the nucleus is tiny little small thing sort of floating in the middle of a giant volume in which electrons whiz around. Now, if you have an electric charge that's moving, you create a magnetic field.
In some metals, like iron, clumps of atoms line up and point their poles in the same direction. We call these clumps domains. All magnets, large or small, have them. The biggest of all magnets are planets and stars. Both the Sun and the Earth have magnetic strength. The force of magnetism, coming from a piece of steel or a planet, is called the magnetic field. You can visualize a field with a bar magnet and some iron filings. Sprinkle the filings over the magnet, and you'll see the field is uneven. Drawn by the strength of the magnetic force, field lines converge where the force is strong and spread out where it's weak. The Earth's magnetic field lines converge at the north and south poles, and electrically charged solar particles act like iron filings. Out here, magnetic lines are colored by light. Tiny remnants of the Sun collide with molecules in the Earth's atmosphere and trace magnetic lines with ghostly auroras. Only people living in the far northern and southern latitude bear witness to our planet's magnetic force at work. But while the force may be invisible to the rest of us, its effects are visible to us all. On Earth, magnetism tells us where we are and helps us communicate. It drives machines. In the atmosphere, the magnetic force shields the planet from too much radiation and, quite simply, allows life to exist. The Earth's magnetic field is as old as the planet. It flows out of the core of the planet and reaches 36,000 miles out into space. This magnetosphere shields us from cosmic radiation and blocks most of the particles streaming towards Earth on solar winds. The Earth's magnetic field lines converge at the north and south poles, but the magnetic poles and the geographic poles don't always line up. Here's why. Traveling to the core of the Earth, we find hot liquid iron kept in motion by the Earth's spin and thermal currents. The flowing iron creates electrical currents and our magnetosphere. But disturbances in the flow cause gradual changes in the field, and over time, the magnetic poles drift. Rock-solid evidence of these magnetic pole changes exist in California's Death Valley. When rocks form, some of their particles line up with the Earth's magnetic field. When scientists dig into the layers, samples dating back 700,000 years record a consistent north-south alignment. But older layers tell a different story. Compass needles haven't always pointed north. Geobiologist Joseph Kirschvink explains.
And one of the strangest things in geomagnetism is the magnetic reversal. The idea that the entire planetary magnetic field can come discoupled from the rotational axis. Instead of pointing north, the magnetic field might be pointing east for a while, and then reestablish itself, and your compass needle will point south.
Rock samples are analyzed in a magnetometer to determine the strength and direction of magnetic fields over time. The historic record shows that since the year 1670, the strength of our magnetic field has declined by 15%, while its direction has stayed the same. If we're in the middle of a slow magnetic reversal, we can no doubt adjust, but reversals can happen quickly. Volcanic rocks at Steens Mountain in Oregon record ancient magnetic changes of a few degrees a day. A quick reversal in our magnetic fields would mean chaos. Cities would be left without power. Compasses would fail to guide us. Migrating animals wouldn't know where to go. In short, the world would turn upside down.